All right, so for this equation, I have 7 to the power of x plus 7 to the power of x plus 7 to the power of x is equal to 777. So I want to find the value of x. So to do that, what I'm going to do is factor out 7 to the power of x from my left-hand side because we have the same term 3 times. So now I get 7 to the power of x times 7 to the power of x divided by 7 to the power of x is 1. So I have 1 plus 1 plus 1 is equal to 777. Now 1 plus 1 plus 1 is 3. So I get 3 times 7 to the power of x is equal to 777. Now I'm going to divide both sides by 3. So these two cancel out. And I get 7 to the power of x is equal to 259 because 777 divided by 3 is 259. Now from here, I'm going to take the log on both sides. And the reason I did this is because logarithms have a helpful property that state that if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. And the reason this property is so useful is because right now, as it is 7 to the power of x equals 259, well, 7 to the power of 1 is 7, 7 to the power of 2 is 49, and 7 to the power of 3 is 343. So x is going to be somewhere in between 2 and 3, but we don't know the exact value of x, and we can't solve for it as an exponent. So now, when we drop it down and make it a real term, it's much easier to solve for x. So now what I'm going to do is divide both sides by log 7. So then these two cancel out, and I get x is equal to log of 259 over log 7. And log of 259, I can rewrite that as log of 37 times 7. Now another helpful property of logarithms is that if I have something in the form log a times b, this is equal to log a plus log b. So in this case, log 37 times 7, that's going to turn into log of 37 plus log of 7 over log of 7. And this is equal to log of 37 over log 7 plus log 7 over log 7. So now, these two are going to cancel out, so I get x is equal to log 37 over log 7 plus 1. And now, the final thing to do is to plug in the actual values of log 37 and log 7. So, log of 37 is equal to 1.568, and log of 7 is equal to 0.845. So now log of 37 over log of 7 is equal to 1.856. So I have this plus 1, which is equal to 2.856. Alright, so in this video, I'm going to be teaching you guys how to solve the problem x to the power of 4 minus 16 is equal to 0. So, I know what everyone's thinking to do. You guys are probably thinking to add 16 on both sides, so we get x to the power of 4 is equal to 16. And now, if I take the fourth root on both sides, I get x is equal to positive or negative fourth root of 16. And although this is one of the right answers, we can't actually find all the correct solutions to this equation by using that method. So a better way to actually do this is to first rewrite 16 as 4 squared. So I get x to the power of 4 minus 4 squared is equal to 0. And now x to the power of 4, that's the same thing as x to the power of 2 times 2. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 2 times 2, this is the same thing as x to the power of 2 to the power of 2. Now I have this minus 4 squared is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x squared and b is 4. So I get x squared plus 4 times x squared minus 4 is equal to 0. And this also gives me two equations. I get x squared plus 4 is equal to 0, and also x squared minus 4 is equal to 0. So x squared minus 4, that's the same thing as x squared minus 2 squared is equal to 0. And again, I can use this property, a squared minus b squared is equal to a plus b times a minus b. So in this case, a is x and b is 2. So I get x plus 2 times x minus 2 is equal to 0. And I get yet again another two equations. I get x plus 2 is equal to 0, and I get x minus 2 is equal to 0. So these are fairly simple equations. For x plus 2 equals 0, I subtract 2 on both sides, and I get x is equal to negative 2. For x minus 2 equals 0, I can add 2 on both sides, and I get x is equal to 2. Now for x squared plus 4 is equal to 0, I can subtract 4 on both sides, and I get x squared is equal to negative 4. Now, if I take the square root on both sides, the square root of x squared, which is x, is equal to the square root of negative 4, which is the same thing as the square root of 4 times the square root of negative 1. And if you guys already know, the square root of negative 1 is equal to I. So I get x is equal to positive negative 2i. So I actually have 4 solutions to this equation.